This is section 2.2 in Precalculus class notes. Here we're going to be talking about quadratic functions. Hopefully most people are familiar with quadratic functions. Again, these are parabolas, so we want to know how to graph them. We want to know how to determine their minimum or maximum value, and we want to know solve some problems with them. So the standard form of a quadratic function will always look like this. So f of x equals some constant a, not 0 of course, because we need an x squared, some constant a times the quantity x minus h squared plus k. So when you have something like that, remember if you start off with ax squared, it's going to look like a parabola as long as a is bigger than 0. Okay, if a is bigger than 0. If a is less than 0, it's an upside down parabola. All right. So when you have it in this form, it tells you where to move it. It tells you that you have a vertex at x equals h and y equals k, right? So your vertex is at the point hk right here, which means that instead of having an axis of symmetry of the y-axis, your axis of symmetry will be x equals that h value. Same thing on whether a is greater than 0 or less than 0. You still have your axis of symmetry being that x equals h. Okay? So when you graph quadratic functions, you want to determine whether they open upward or downward based on what the leading coefficient is, whether it's positive or negative, what its vertex is. Then you can go further and you can find x-intercepts by solving for the roots, f of x equals 0. You can find the y-intercept by computing f of 0. And you can plot the intercepts, the vertex, and additional points as necessary, but you can always use symmetry too because quadratic functions are always symmetric with respect to the axis of symmetry, of course. So completing the square is the technique that you often need to do to get a quadratic into that standard form. So for example, here in example 1, we want to look at f of x equals minus 3x squared plus 5x minus 4. The first thing we should recognize is that the minus 3 means that it will open downwards. But I don't have any idea where the vertex is in this form. So I need to factor that minus 3. I need to take just the x terms, the minus 3x squared plus 5x, factor a minus 3 out. That means I would have minus 3 out of there, so x squared, but then I need to divide this minus 5 by 3. I'm sorry, divide the 5 by minus 3. So this becomes plus 5x, right? So in other words, I'm factoring minus 3 out of the whole thing. Now this is what I need to complete the square, and I write my minus 4 over to the side. So how do I complete the square? Remember, you take half of that term. So in this case, that would be minus 5/6, right? Minus 5/3 times 1/2 would be minus 5/6. And you square that, and that's what you add. All right. Now, it's really minus 3 times that because the minus 3 was factored out. So if I'm going to add, in other words, I'm going to actually subtract minus 3 times that, I got to add it back in so I haven't changed the problem. So what that does, it allows this now to be a perfect square. So I have minus 3 times the quantity x minus 5/6 squared. That tells me the x value of the vertex. And then I have to simplify these constants together. So when I do that, I end up with minus 23/12. So the vertex is at 5/6 minus 23/12. All right, let's take that further with a second example of a quadratic. This would be an upwards opening parabola because I have a positive coefficient in front of the x squared term. Second thing I want to do is find the vertex, so I got to complete the square again. Take a look at that, make sure you know how to do that. Put it in standard form. So your vertex would be at 5/2 minus 1/4. Okay, which means your axis of symmetry, by the way, is x equals 5/2, right where the vertex is. So everything on either side of that axis of symmetry will look similar, be symmetric. Then I want to set the quadratic equal to 0 and solve for the roots, which gives me the x-intercepts. That can be factored, which is nice. So you get two x-intercepts, x equals 2 and x equals 3. And I plot those. So vertex here, two x-intercepts. Then I'm going to plot the y-intercept by solving f of 0. When x is equal to 0, what's y? It's 6. So there is the y-intercept, which means that because it's symmetric about this line, I'm going to have the point 5/6 on there as well. And that's how you get a quick graph of a quadratic. All right, as a third example, let's determine without graphing whether this function f of x has a minimum or a maximum value. All you want to know is, does it open up or does it open down? Okay, we have a positive coefficient in front of x squared, which means it's an upwards opening quadratic like this, which means it would have a minimum value, no maximum. So now let's find it. Well, to find it, you have to figure out where the vertex is. Okay, so you have to complete the square. Go through and complete the square. Get it into standard form. So the vertex is at 1 minus 4. That means the minimum value is the y value of minus 4, and it occurs at x equals 1. Identify the domain and range. So the domain of a quadratic is always minus infinity to infinity. The range is, because I know the minimum value is minus 4, it goes from minus 4 to infinity, including minus 4. As a last example, this is sort of a word problem, but this is a typical type word problem you could be asked that are quadratic, resulting in quadratics. Let's say we have among all pairs of numbers whose sum is 50, find a pair whose product is as large as possible. And then what is this maximum product? So we got to call the first number something, x, and so the second number would be 50 minus x because these have to add up to 50. Right? X plus 50 minus x has to add up to 50. So the function itself would be the product of these two numbers, x times 50 minus x, or 50x minus x squared, which is a quadratic. It's a downwards opening quadratic, so it will have a maximum value, no minimum. So then I complete the square to see where that maximum value is because it'll occur at the vertex. Complete the square, I get this quadratic into standard form, which means the vertex is going to be at 25, 625, right? So the maximum value is the y value, 625, and it occurs at x equals 25.